Okay, in this podcast we're going to talk about solution concentrations, specifically molarity and dilutions. So because we usually are using solutions to get reactions to occur, because we need the ions to be mobile, that we do a lot with solution concentration. So we can talk about qualitatively that I have a dilute or a concentrated solution. But usually we need to be quantitative, and we need to give specific numbers or values for just how dilute or how concentrated. And we can talk about things like a percent concentration. So you can say for instance, a 3% sodium chloride solution, which would suggest that for every 100 grams of solution, 3 grams comes from the sodium chloride. But the way we talk quantitatively about solutions is almost always about molarity. So that's what we're going to focus on. So molarity is one way of expressing concentration. It's just one way, but it's the most common way. And the definition of molarity is the number of moles of solute. So if I'm making a solution of sodium chloride, the solute will be the solid sodium chloride salt, right? So I want the moles of the thing I'm dissolving over the volume of the total solution in liters. So if I'm putting sodium chloride in a volumetric flask and then I add water up to 1.0 liters, the total volume is 1.0 liters. Okay, so a couple of other things you need to be aware of. So, of course, like we said earlier, because molarity is moles over liters, when I'm doing stoic or I'm trying to find moles I have in a solution, moles is going to be molarity times liters. And why that works is molarity, big M, is moles over liters times liters, and the liters cancel out, right? Now, the other thing you need to know is that often in AP Chem, or chemists in general, use brackets to indicate molarity. So if I were to say, find the bracket with silver nitrate inside, I want you to find the molarity of the silver nitrate solution. So when we talk about, and sometimes we'll just say the term concentration, what is the concentration of the solution? We are always talking about molarity. Okay. So molarity, if I wanted to make a solution of sodium chloride, or if I said find using 1 mole of sodium chloride to make 1 liter of solution, then my molarity, which is what I'm asking about here, is the moles of that over the liters of that. So the moles of the solute is 1, the liters is 1, so my molarity is 1. And the molarity stands for moles over liters. Okay. So let's say I have 25 grams of calcium chloride, which I'm assuming I'm starting with a solid, and I'm going to create 300 milliliters of solution. Now this is really worded wrong. I should have said if you dissolve 25 grams of calcium chloride up to 300 milliliters of solution, what is the concentration? It will come out very close to what this is, but that mass of the calcium chloride does take up a little bit of space. So let's assume that I said 25 grams of calcium chloride in 300 milliliters of solution. So my molarity is my moles over my liters, and my moles of solute is going to be this 25.0 grams of calcium chloride over the molar mass of calcium chloride, which is 110.98 grams of calcium chloride, over liters. So what I have is 300 milliliters, so 300 milliliters divide by 1,000 milliliters, because there's 1,000 milliliters in a liter. And pretty quick you're going to get to realize that that is just simply 0.3 liters. We do this enough that it becomes pretty easy to do after a while. So it's 25.09 grams in your calculator, divided by 110.98 equals, and then divide by, and then 300 over 1,000 equals, and you should get 0.751 molar, or 0.751 moles per liter. Okay, so let's take a look at doing a problem involving dilution. So this is something I do all the time, and you will do it pretty frequently as well. So let's say I want to make 500 milliliters of let's say a 1 molar solution of some salt, okay? I have two choices for how I'm going to make it. One is I could go ahead to the stockroom and take out the reagent bottle that's going to have a solid, and I can dilute it, put it in a volumetric flask and dilute it with water up to a certain line. Or I can take a stock solution. So this is something I have in my stockroom, which is why we call it a stock solution. It's already made up. And maybe this is 5 molar. And I take that 5 molar and I add additional water to it, and I make the concentration that I'm looking for. So before we talk about doing any calculations about this, I want you to just think about this question is, if I start with, let's say the number of particles, the purple particles here represent the number of moles I have. So if I were to take, let's say, 100 milliliters of this, looks like 6 molar solution, and I add water to it, and I go up to 500 milliliters, I have a more dilute solution, so it's not going to be 6 molar anymore, but I want you to think about how many moles of particles do I have now. So if I look at it, I still have the same 6 particles, so I still have 6 moles, and here I have 6 moles, okay? So if I am diluting something, I have the same number of moles of particles before the dilution as I do after the dilution. And that's important because that tells us, when I do a dilution and I want to figure out a constant, I want to figure out how much of each I need and what I'm going to get, what I need to remember is that the moles in the concentrated sample is equal to the moles in the dilute sample, okay, after I've added water to it. And like we said, because molarity is moles over liters, moles is molarity times liters. So I can replace each of these. I can say the molarity of the concentrated times the liters of the concentrated equals the molarity of the diluted sample times the liters of the diluted sample. And when I do that, I can solve for any one of those things. So let's take a look at how that might work. So here is a schematic that actually shows how I would go about making a dilution. So I want to prepare, I want to prepare 3.0 liters, right? 3.0 liters. So I'm going to use a 3.0 liter volumetric flask, right? I can't use a 2 liter volumetric flask or a 5 liter because there's only one line on the flask, right? So these are for making volumetric flasks we use for making solutions, and it's for making a specific quantity. I use the size for the quantity I want to make. And I want it to be 0.5 molar of calcium chloride. Okay, and I go to my stockroom, and what I have is 0.150. Well, let's back up a little bit. Even before I know how much of the solution I'm going to add, what I want to know is, I want 3 liters of a 0.500 molar solution. Okay, and what I have in my stockroom is a concentrated 10.0 molar solution, also of calcium chloride. So what I always have to do is I have to figure out how much of this, how many milliliters or liters of this do I need to put into this 3 liter flask, and then fill up to the line with water in order to get what I want. Okay, so here is our dilution formula. It's really rewriting what we just talked about. We said MCVC equals MDVD. Most people will say this is M1V1 equals M2V2. So I can say I have 10.0 moles per liter, which is the same thing as what molarity is, times, this would be my X to start with. I don't know how much of that I need, but I know I want 0.5 molar, which is 0.5 moles over liters, and I want to make 3 liters. And if I were to solve for this X, what I get is 0.150 liters, right? And 0.150 liters is 150 milliliters, okay? So the way I would actually make the solution is I would take in this case, I would take a graduated cylinder because I'm using 150 milliliters of the concentrate. And while we said we're going to use a dispensing pipette to get real precision and real accuracy in our solutions, here I'm making a lot. Okay, and the fact that I'm making a lot actually helps lower the tolerance. Okay, so it's more accurate. So I normally would use a pipette if I'm using small quantities. I'm making something very accurate. But if I'm using 150 milliliters, I'm going to need to use a graduated cylinder. So I take that 150 milliliters, measure it in the graduated cylinder, I add it to the flask, and then I dilute it with water up to the line. And then I shake it, and I have my solution. Pretty easy to make. So let's take a look at a couple problems we could use with doing a dilution. So in this problem, it says if I have 54 milliliters of 1.54 molar sodium chloride solution, and I dilute it to 0.110 molar, how much dilute solution can I make? And this is actually something that I often ask myself when I'm trying to make stuff for a lab. I have a certain amount in my stock room. I know what its concentration is, and I want to know how much I can make and whether I'm better off just making from solid. So if I take M1V1 equals M2V2, and it doesn't really matter whether it's the concentrated one on this side and the dilute on this side or vice versa, as long as the concentrated M and V are together. So if I have 54.0 milliliters of 1.54 molar, right? And I want to dilute it to make 0.110 molar. The question is, how much dilute solution can I make? So I don't know what the volume is going to be, so I'm going to make that X. Now, one of the things you might ask yourself is this is 54 milliliters. It's not liters. It's not molar times liter. So let's just take a look. If I were to change this to, let's call this, changed it back to purple. If I were to make this moles over liters and this moles over liters, when I'm solving for X, what I'm going to have is 54.0 milliliters times 1.54 moles over liters over this, which is 0.110 moles over liters. So this moles over liters and this moles over liters cancels out. So if I were to multiply 54 times 1.54 divided by 0.110, what I get is 756 milliliters. Okay? So part of what we've just uncovered is that if I do my M1V1 equals M2V2, the units for volume can be anything as long as they are the same on both sides, because the molarity units are going to cancel out. Okay? So it could be ounces, it could be gallons, it could be liters, it could be milliliters. Okay, let's take a look at one more. So in this problem, I'm going to say if you need to make 750 milliliters of 1.0 molar sodium acetate, how many milliliters of 2.5 molar sodium acetate will it take? Pretty typical. I want to make 750 milliliters of 1.00 molar, and I want to know how many milliliters of 2.5 molar, and this is what I'm trying to figure out, milliliters, right? So I'm going to divide both sides by 2.50 to isolate my x, and when I do that, what I get is 300 milliliters, 3 sig figs, right? 300 milliliters. So what that says is I'm going to use 300 milliliters of the concentrated solution that I put into my flask, and then I add water up to the line. Okay, so we're going to stop right there.